Okay, so now we'll talk about utricle and sacral balance and equilibrium. I will use the video with such title from the YouTube by Psychotic. Please like this video. Of course, I will add something from my own, like always. Today, maybe even more than usually.
The external ear, middle ear, and inner ear. The inner ear contains the spiral-shaped cochlea, where sound waves are...
Yeah, so cochlea, just to be precise, is a place where we have an organ or corti, about which we will talk more later, where we generally decode information from the sound waves into the electrical signal that can be recognized by the brain.
Transduced into neural signals, and the vestibular complex, which contains the receptors for our sense of equilibrium. The central
A sense of balance and equilibrium generally. So with closed eyes, we know where our head is, thanks to the proprioception, but also thanks to the sense of the balance generally. And it also helps us to feel acceleration. Generally, it's mainly about feeling the acceleration.
egg-shaped cavity is the vestibule, which contains a pair of membranous sacs, the saccule and the utricle. Inside the utricle and saccule are hair cells similar to those in the organ of Corti. The hairs are clustered in the macula, where their processes are embedded in a gelatinous mat.
So this is very important, that these hairs can move. In a moment you will see, but concentrate on those hairs.
And lie under a thin layer of crystals called otoliths. When the head tilts, gravity moves the crystal mass and distorts the stereocilia of the hair cells. This is how the
So this movement is caused by the movements of heads in case of the cochlea and vestibule. Yes. So for example, some accelerations. Let's imagine that we are riding in the car. Yes, and we keep the glass with water in our hands. When the car would accelerate fast, the water may just get out of the glass because the acceleration would accelerate as faster than the water inside. Here is the same with those with this mucus, with those crystals above. This acceleration, linear acceleration in case of the utricle, will lead to the flexion of the hairs, and it will be transducted into electrical signal that can be recognized by the brain.
Saccule and utricle provide information about position with respect to gravity. Behind the vestibule is the third portion of the bony labyrinth, known as the semicircular canals. The canals project from the posterior region of the vestibule and are responsible for the detection of head motion in three spatial planes.
So they detect angular acceleration, yes? I will show it a bit later, but generally this is very important. So the semicircular canals are generally recognizing the angular acceleration.
The anterior duct senses forward and backward motion. The posterior duct detects moving up and down. The lateral duct senses moving left to right. Each canal contains a membranous semicircular duct where angular momentum is sensed. At the base of each duct is an expansion called the ampulla. Within the ampulla, long stereocilia of hair cells are embedded in the cupula, which sticks out.
So the idea is quite similar, yes? Maybe not exactly the same, obviously, but it's quite similar. We have some hairs that sticks out. This is similar also in case of the organ of Corti, that when moved will create the electrical signal that will get to the brain. In here we have the ampulla, so generally that recognizes from which side of the semicircular canals the fluid flows, from left to right or from right to left, from top down or down top. And this ampulla would just flow in the appropriate direction, and this movement of ampulla would be felt by these hair cells. However, still the same critical idea is everywhere in the inner ear. So we have some hairs that when moved will create the electrical signal.
Into the endolymph. When your head moves, the endolymph moves the cupula and stimulates the stereocilia.
Okay. So, generally, one more time about the semicircular canals, because I suppose it may not be completely clear. It's not as easy. Okay, so this blue thing is a cupula. And the red one is generally the semicircular canal. Inside we have some fluid, yes? So, when the head tilts in some direction, the fluid, for example, we tilt the head in this direction, yes? We accelerate the head in this direction, yes? So the fluid would also flow, yes? And we will see, well, we will feel that the ampulla is moving into some direction. It's shifting, yes, because when the fluid is shifting in one direction or the other, the ampulla is also shifting in one direction or the other. And we will feel this shift, and that's how we will recognize that there is some angular acceleration that's happening. Okay. About the balance, I suppose it's clear. About the hearing. So now, we have the vibration that gets, you already know from the previous lesson, that gets to the organ of Corti. So, to the inner ear, but to the part of the inner ear that is responsible for hearing. Yes, so we have the scala vestibuli, scala tympani, cochlear duct, generally. And here we have this critical part, so we have the organ of Corti. The organ of Corti has the same idea that everywhere. So we have something attached to the herses, to the stereocilia, generally to the stereocilia. And when this would move, the information would pass to the nerves and then to the brain. Generally, when it happens, the movement in case of these hairs in the organ of Corti would happen when the vibration would hit this spot. Yes? So you already know that the sound is a vibration. So when this vibration, when this change of pressure, because generally vibration is about the change of pressure. So when this change of pressure would hit here, it would flex the hairs and it would be felt by the cells and they would produce the electrical signal that would be transduced to the brain. Okay, I suppose it's quite clear. If you have any questions, you can post them on the classroom. Okay, thank you very much.